Alright, this video we're going to talk about pyramids. And pyramids are just polyhedrons with one base, all the sides are triangles, and all the sides intersect at a point called the vertex. So the vertex is this top point here where all the sides intersect, and here you can see some examples of some pyramids. And pyramids are named by the shape of their base: rectangular pyramid, hexagonal pyramid, triangular pyramid. Here's also some other examples, some little three-dimensional examples of a couple of pyramids. Now I want to make a note about regular pyramids. Regular pyramids are going to be the only type of pyramids that we're going to look at in this section. And for regular pyramids, the base is always a regular polygon, and all the sides are congruent triangles. And these two features of regular pyramids are going to make it a lot easier for us to calculate the areas of the pyramids, the base area and the lateral area. So let's take a look at how we calculate the base area. Well, the base area of a pyramid is just the area of the one base. So for a rectangular pyramid, and since it's a regular pyramid, that means we have a regular rectangle, which is a square. The base area is just the area of a square. Well, one side of my square is 8, so my base area here is 64 square meters. In my second example, or rather in example 1b, my pyramid is also a square pyramid, just the dimensions are slightly different. I've got dimensions of 10, so I want to calculate the area of that base, and that's just 10 times 10, which is 100. In this case, it's inches, so 100 square inches. Now, in example 1c, I have a hexagonal pyramid. And you'll notice in a lot of these drawings that I've got here, I've left off some of the dimensions that are labeled on the pyramids in your notes. That's just because we're not going to be using all of the dimensions in each one of the examples. So for my hexagonal pyramid, I want to calculate the base area, which means I need to calculate the area of a hexagon. So let me draw my hexagon base out over here. So here's my hexagon. The length of the side of my hexagon is 5 feet. And notice here in my picture, I'm given the length of the apothem of my hexagon, which is going to be handy because I know the area of a hexagon is 1/2 times perimeter times apothem. Well, my apothem here is 4.33 feet. So I've got everything I need here to calculate the base area of my hexagonal pyramid. Let's see, my perimeter, I've got the length of one side is 5. I've got 6 sides, so my perimeter is going to be 5 times 6, which is 30. My apothem is 4.33 feet. And if I multiply all those numbers together, then I get 64.95 square feet. And that's the base area of my hexagonal pyramid. So now let's look at lateral area. Lateral area of a pyramid is the area of all the sides of a pyramid. Remember, the sides of our pyramids are always triangles, and in fact they're all congruent triangles, which means that once we find the area of one of our side triangles, we just have to multiply that area by however many sides we have. Now, in order to find the area of one of our side triangles, we need to introduce this term called slant height. And the slant height of a pyramid is just the height, it's the distance from the vertex of the pyramid down one side of the triangle and perpendicular to one of the edges of the pyramid. So this dotted line here in orange is the slant height. And I've also drawn it on here. I'm not sure if you can see it on this pyramid. The slant height is just going to be this distance right here, and I've kind of drawn it on there in a dotted line. I don't know if you can see that well. So if we know the slant height of our pyramid, then we can calculate the area of one of our side triangles. And so the area of one of these side triangles is going to be the area of a triangle, 1/2 base times height. Well, base is going to be the length of the base of my pyramid, and the height in this case is going to be the slant height. So let me just say slant height. And then once we find that, we multiply that times however many triangles we have. So let's take a look at example 2a. I've got this square pyramid, the same one we looked at in example 1. And let me draw out one of my side triangles here. And let me put in my slant height here. Slant height is 6 meters. And I know what the length of the base of my triangle is because it's given to me right here, so 8 meters. So now I just need to calculate the area of that triangle. Well, that's 1/2 times area of that triangle. 1/2 times base times slant height. It's 1/2 times 48, which is 24. Now to calculate my lateral area, since I have 4 of these triangles that make up the sides of my pyramid, 4 times 24, which is 96, and let's see, I'm in square meters. And there's my lateral area. Now in example 2b, I've got a slightly different case because notice in this one I'm not actually given the slant height. I'm given instead the length of one of these edges of my pyramid. So before I can calculate my lateral area, before I can calculate the area of one of my side triangles, I first have to figure out what is the slant height. So again, let's draw this triangle over here. So here's one of my side triangles. I know the length of my base is 10 inches. And I know the length of this side here of my triangle is 13 inches. But I don't know my slant height. And I need to know that height in order to calculate the area of this triangle. So, well, I can calculate that slant height because I know that this altitude is going to divide my base into 2 congruent segments. So the length of this piece is going to be 5. Well, now I've got a right triangle, and I can use the Pythagorean theorem. So let's see, my Pythagorean theorem, I'm going to say 5 squared plus, and this will be, call this my slant height. 5 squared plus slant height squared equals 13 squared. So that's going to see 25 plus slant height squared equals 169. And if I do that arithmetic, then I get my slant height is equal to 12. Now I know my slant height, I can calculate my area of my side triangle. So that's going to be 1/2 times the base, which is 10, times the slant height, which is 12. And that equals 1/2 times 10 times 12 is 120. So that's 60. Now that I know the area of one of my side triangles, I need to multiply that by 4 since I have 4 triangles. And my lateral area is going to be 4 times 60, which is 240. And this is in square inches. Now the next example, example 2c, you have to calculate the lateral area of a hexagonal pyramid. And this one actually is a lot easier than it looks. I'm going to leave that one for you to do, and we'll take a look at that answer tomorrow in class. Now, the next section in your notes, we talk about total area. And total area, again, this is similar to some of the solids that we've already looked at. The total area of a pyramid is just the base area plus the lateral area, or BA plus LA. And for example number 3 in your notes, it says find the total area for these same 3 pyramids that we've been working with. And again, I'm going to leave that for you to do since you've already calculated the base area of each of those pyramids and you've already calculated the lateral area for each one of those pyramids. You should be able to calculate the total area without too much trouble. So let's go on now and talk about the volume of a pyramid. So the volume of a pyramid if you remember, the formula for the volume of a sphere, the volume of a prism was the area of the base of the prism times the height of the prism. Well, the volume of a pyramid is not going to be exactly that, because if we calculated for example, the area of the base of this pyramid and multiplied it times the height of the pyramid, well, we would just get the area of a prism and not the area of a pyramid. Turns out the volume of a pyramid, it's less than the volume of a prism with those same dimensions, and it's less by that much. So the volume of a pyramid is 1/3 times the area of the base. This is area of the base times the height of the pyramid. And the height of the pyramid, and this one right here, you can see this orange line right here. The height of a pyramid is just a line that goes from the vertex of the pyramid, and it's perpendicular to the base, and that actually drops right down. For a regular pyramid, that line goes right to the center of the base of the pyramid. So let's take a look at how we would calculate the volume of these pyramids. Example number 4. So I've got my formula here, 1/3 times area of the base times the height. Well, in this example, I already know what the area of my base is because I calculated that back in example number 1. So the area of my base is 64. And also for this one, I've already been given the height of the pyramid because I can see in my picture, I've got a line that goes from the vertex, it's perpendicular to the center of the base, and that's 5 meters. So I just plug in those numbers to my formula, 1/3 times area of the base times height of the pyramid. And if I punch in those numbers, I get 106.67, and my units are meters here. And now since I'm talking about volume, that's going to be cubic meters. Now in example B, I again am going to use my same formula, but I don't have given to me the height of my pyramid. I know what the area of the base is, because again I calculated that in example number 1, but since I don't know what the height of my pyramid is, I'm going to have to calculate it. And the way I'm going to do that is, again, I'm going to break out a triangle from this figure, and the triangle that I want to break out is going to be this triangle here. Draw on this other orange line. I'm going to break out this orange triangle right here. And that orange triangle, this side of the orange triangle is the height of my pyramid. The hypotenuse of my orange triangle, this is going to be my slant height. My slant height I know because I calculated that back in a previous example. And the other side of my triangle is going to be this distance here. Well, this distance here is just the distance from the center of my base to the edge. That's going to be half of this whole edge length. So since that whole edge length is 10, I know that half of that distance is going to be 5. Well, once again, I have a right triangle, and I can use my Pythagorean theorem to calculate the value of h. So h squared plus 5 squared equals 12 squared. And now if I do the arithmetic on that, then I come down to h is equal to 10.9 inches. Well, now I know the value of h, which is the height of my pyramid. I already know the area of the base of my pyramid. Now I can calculate my volume. Volume is 1/3 area of the base times the height. The area of my base here is 100. The area of my height, the value of my height is 10.9. And if I multiply those numbers out, I get 363.3. My units are cubic inches. Now, example 4C, I want to calculate, again, the volume of my hexagonal pyramid. Once again, I already know the area of my base because I calculated that in a previous example. But once again, I don't have the value of the height of my hexagonal pyramid, so I'm going to have to calculate that, and I'm going to calculate that similar to the way I did on the previous example. And what I'm going to do is I'm going to note that here's the height of my pyramid, this orange line here. I already know the slant height of my pyramid, that's 10 feet. I also already know the apothem, which is the distance from the center of my base hexagon, perpendicular to the opposite side. And in fact, I'm going to break out this triangle right here, which is a right triangle. Notice my apothem, which is given to me as 4.33 feet. That's also, I just drew another apothem over on this side. I'm going to take this orange triangle and break it out over here. So this orange triangle is, there's my right angle right here. The length of my hypotenuse, 10 feet, that's my slant height. The length of this leg of my triangle is 4.33 feet. And I'm trying to find this value here, h, which is the height of, it's the distance, the length of this side, but it's also the height of my hexagonal pyramid. And once I know that height, I can calculate my volume. Well, I've got a right triangle. I know 2 of my 3 sides. I can use the Pythagorean theorem. So h squared plus 4.33 squared equals 10 squared. And I get h squared plus 18.75 equals 100. And if you do the rest of that arithmetic, you should get h equals 9.01. Well, now I know the height of my pyramid. I already calculated the area of the base of my pyramid. Now I can just plug into my formula. Volume is 1/3 area of the base times height. That's 1/3. The area of my base is 64.95. You can look back at that previous example and get the area of the base. The height, I just calculated that, is 9.01. And if I multiply all those numbers together, I get 195.15 cubic feet.